Hello, PhotoPiller, Rafael the bar here. When it comes to Milky Way photography, because we're photographing at night, we need to use long exposure times to allow as much light as possible to reach the sensor. The more light the camera collects, the more stars will capture in the photo, with one limitation: star trails. Yes, due to the rotation of the Earth, when photographing the Milky Way, we need to limit the exposure times we use to prevent the stars from trailing and get pinpoint stars in our photos. So the question is, what's the exposure time that we need to use? Well, it depends on many factors. Let's see how to calculate it. Go to PhotoPills, and in the Pills menu, swipe up until you see Spot Stars and tap on Spot Stars to see the Milky Way exposure calculator. Here we need to set many parameters, but the first one is the camera. Why the camera? Well, it turns out that the Milky Way exposure time depends on the pixel pitch of your camera. And what's the pixel pitch? The pixel pitch is the width of a pixel on the sensor. It depends on the sensor size and on the megapixels of your camera. The smaller the pixel, the shorter the exposure time needs to be in order to prevent star trails. This is because the higher the resolution of the camera, the more detail is captured in the photo, and the movement of the stars is more perceptible. So select your camera. Let me select the camera we always use for Milky Way photography in the PhotoPills team, which is the Nikon Z6, and let's continue. The aperture is another factor we need to take into account. The wider the aperture, the smaller the stars will appear in the photo. On the contrary, the smaller the aperture, the larger the stars will appear in the photo. So if the diameter of a star increases, the star can move along a longer distance before the trail is perceptible, and the exposure time can be longer. In conclusion, the wider the aperture, the shorter the exposure time needs to be in order to avoid star trails. Let's see this effect in an example. Now the aperture is set to 1.4, and the NPF rule is giving me an exposure time of 4 seconds, 437 seconds. Let's see what happens when I close the aperture a bit. Let me plug here an aperture of 2.8, for example, and now the NPF rule is giving me 5.32 seconds, an exposure 1 second longer. So when I close a bit the aperture, I can shoot a slightly longer exposure time and still prevent star trails. Great, as you know, in Milky Way photography we usually use wide apertures. An aperture of 2.8 is great, so I'll stick with it. Let's continue. The focal length and the declination of the stars work together. Let me explain it. Let's have a look at the augmented reality view. Tap on the AR, and here what you see is the horizon, and the dots you see moving on these blue circles, circumferences, represent the movement of the stars, represent the stars moving. And as you see here in the northern hemisphere, the stars near the Polaris, the stars near to the north celestial pole, appear to move slower. The same happens with the stars near the south celestial pole. The stars appear to move slower. And as we get closer to the celestial equator, which is this thick blue line here, the stars appear to move faster. So the closer a star is to the celestial equator, the shorter the exposure time needs to be in order to get the star as a dot, as a point in the photo, in order to prevent the stars from trailing. These blue lines you see on the AR view represent the star trails pattern you'll get depending on the shooting direction. For example, if I'm shooting and framing the Polaris, I'm gonna get the stars describing circles around the Polaris. The same happens in the southern hemisphere with the south celestial pole. You'll get stars trailing around the south celestial pole. But here in the northern hemisphere, when I'm framing south, I'm getting the stars describing arches above the landscape, which is a pretty cool pattern. So planning the star trails with the augmented reality view is super easy. Actually, I'm leaving a link here to a video where I explain you how to do it step by step. Watch it, it's a great video. So for a given focal length, if you include the stars that are on the celestial equator, you'll have to use a shorter exposure time, because the stars appear to move fast, as you see here on the augmented reality view. Well, the parameter that determines how far a star is from the celestial equator is the declination. The stars on the equator have a declination of 0 degrees. The stars that are near the Polaris have a declination of 90 degrees. And the stars that are near the south celestial pole have a declination of minus 90 degrees. So the stars with smaller declinations move faster, and the fastest ones are the ones that are on the celestial equator. So going back to the calculator, as a declination, I recommend you to set 0 degrees, because you're going to be on the safe side, you're going to get shorter exposure times. And as the focal length, just introduce the focal length you're planning to use for the photo. For Milky Way photography, we usually use wide-angle lenses, so I'll set a focal length, for example, of 14 millimeters. Cool. Before we continue with the last parameter, if you want to automatically introduce the declination of the stars, you can use the AR view. If I tap on AR, here at the bottom, what you see is the exposure time depending on the declination of the stars. For example, for a declination of 0 degrees, I'm getting an exposure time of 18.48 seconds, 18 seconds. But if I point the camera up, for example, here to get the minimum declination of the stars of 19, 20 degrees, then I can shoot a exposure time of almost 19.5 seconds, so 19 seconds, 1 second more. This is how you can automatically set the declination of the stars. But as I said, I recommend you to set a declination of 0 degrees. It's much easier. Okay, we've set the camera, we set the focal length, the aperture, the declination. The last setting we need to set is the accuracy. So tap on default, and here you'll see that you have 2 accuracy modes, default and accurate. In the accurate mode, when calculating the exposure time, the calculator allows the star to move its radius in the final image. This assures that the stars still look like a circle. The ratio between length and height is less than 1.5. I recommend you to use the accurate mode if you plan to print your photos in a large, super large format. Otherwise, always use the default mode. In the default mode, when calculating the exposure time, the calculator allows the star to move its diameter, so you'll get a long exposure time. This is actually the mode we usually use, because we're super happy with the photos we get. So let me keep default as the accuracy mode. Now, if you're wondering why the ISO is not taken into account when calculating the exposure time, remember that when photographing the Milky Way, we need to collect as much light as possible. So we need to shoot a long exposure time, but always preventing star trails, of course. Once you've decided the focal length, the aperture, and you've calculated the exposure time you need, then you need to adjust the ISO in order to get the photo correctly exposed. So the ISO comes last when exposing your Milky Way photos. Fantastic! Once all the settings are introduced, the calculator gives you 2 values to play with, the NPF rule and the 500 rule. The 500 rule calculates the exposure time as follows. Take 500 and divide it by the crop sensor of your camera and by the focal length you're planning to use. It gives you longer exposure times than the NPF rule. It's less accurate. You probably get star trails in your photos. In this example, the 500 rule is giving me 36 seconds of exposure time. That's a lot. The NPF rule stands for aperture, photo size, and focal length. The N is the aperture symbol. The P represents the photo size of your camera. And the F is the focal length. The NPF rule takes into account all the parameters we will set, so it's more accurate and usually gives you shorter exposure times than the 500 rule. So I recommend you to use the NPF rule when calculating the exposure times for your Milky Way photos. Having said that, take it as a starting point and play with different exposure values. Experiment a bit, take different photos and see the results you're getting, till you get the photo you like. There are situations where you'll need to use long exposure times. For example, if your camera doesn't allow you to work with ISOs above 1600, for example, because with ISOs above 1600 you're starting to get a lot of noise, a lot of grain in your images, then you'll be forced to use long exposure times in order to get photos correctly exposed. If this is your case, the 500 rule will work best for you. But at the end of the day, it all depends on your gear and on your taste. So experiment with different exposure values until you get the results you're looking for. And that's it. This is how you can easily calculate the exposure times you need for your Milky Way photography. As always, if you have a question, leave a comment below because I'm here to help. And if you wish to learn how to photograph the Milky Way, I'll leave a link in the description of this video to our super Milky Way photography guide. Check it out. If you like this video, give me a like, subscribe, and click on the bell to get notified when we release the next video. And remember that you have the power to imagine, plan, and shoot legendary photos. Bye!